Hello, everyone. This is Saji. We're going to look today congruent triangles. We already know what is congruent is. What is congruent? Figure or shape that have the same size, shape, and measure. Then those two figures are congruent. It can be more than two figures also, all right? So if you take a figure or shape, two of them, and if they have the same size and a shape in measure, then they are congruent. All right. So we already know that. Now we only gonna look into triangles. All right. Triangles are congruent when corresponding sides, corresponding means if you take two triangles, if you take one side and then you take the other triangle and match up with those at that side, whatever that side for the other triangle, that's called corresponding, okay? An interior angle. So triangles are congruent when all corresponding sides and interior angles are congruent. Congruent, we all know what is congruent mean, which is exactly the same thing, all right? The triangles will be the same shape and size, but one may be a mirror image of the other, all right? That's what congruent triangles. So if you take two triangles and put on top of each other, it's going to fit right exactly same. All right. So my question, do we need to know and confirm all the sides and the interior angles are congruent to the other one, other triangle? Do we? Just pause it and give a guess or like think about it and then look into this. We actually don't need it. All three sides and all three angles, which is interior angle. We need, which is calling SSS, which means sides, which is three sides. So if you take two triangles, if you have corresponding sides of those two triangles are congruent or exactly equal, then those two triangles are congruent. In that case, we don't need to worry about the angles. There is another case, also those two triangles are congruent, which is side, angle, side. That's mean if you have a side and another side, and those two sides together make an angle, which is included angle. That's why we put the angle in the middle. Then those two triangles are congruent. If you take two triangles, we have two sides, and those two sides create the angle, then those two triangles are congruent. We don't need to worry about the third side and other two angles. The third one is angle, side, angle. So if you have an angle and then another angle, in between those two angles, there's a side on one triangle and it has the same exact another triangle with the same angle and the same two angles and the side between those angles, then if you take those two triangles and put together, it will exactly fit, which is called congruent. Or if you have two angles, doesn't matter which angles, then a corresponding sides for both triangles are same, then those two triangles are congruent. So we don't need to worry about if we have those three those three categories are fitting to two triangles, then we don't need to worry about the other side or other sides or angle. So if you get Two triangle, if you can prove either four of these, and then those two triangles are congruent. Then if you measure the third angle or third side that you are missing, then they will be exactly equal. All right. We have a special triangle, which is called right triangle. In right triangle, we need to learn hypotenuse, leg. We know what is hypotenuse, which is right opposite of right angle, which is a 90-degree angle. Whatever the side opposite of that right angle, which is called hypotenuse. And L means leg, which is another side. If you have two right triangles and hypotenuse and a leg, it's congruent to another triangle's hypotenuse, another right triangle's hypotenuse and the leg, then those two triangles are congruent. These three of them, we don't need to worry about that much because it's going to fit in here anyway. But we will look into that, all right, in the future. So side postulate, which means SSS, when you write, if you put SSS, I know what it is, which is side, okay? If three sides of a triangle are congruent to its three corresponding sides of another triangle, then the two triangles are congruent. That's what I was saying on the top, all right? Let's look at these two triangles. There's a side called, like a triangle ABC, this is a triangle which is congruent. See the congruent sign? Which is congruent triangle DEF, all right? In those, if we need to prove, we have to give all these three statements to make sure those two triangles has it, and then we can say those two triangles are congruent. Let's say AB is congruent to DE or ED, which is fine. All right. These are congruent because they just put a mark, one bar, that means these two are congruent. And BC is equal to EF. That's why they put the mark over here. So the reason is in here, it's given. And DCA, which is this, which is FD. Those all given, the reason is given. So now if all those three fit in, then you can say triangle ABC is congruent to DEF, okay? Triangle, there's another postulate that we looked into it, which is the second one, side angle side, or SAS postulate. Side angle side postulate, side angle side. If two sides and the included angle, which is very important, included angle mean those two sides making the angle of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So we don't need all three sides and all three interior angle has to match up. If we know all those three and if we confirm, then the rest of it also will be congruent, okay? Look at these triangles. See, side and another side. The corresponding side for this one is this, and corresponding side for this is this. Look at the angle. These two sides that they are congruent to another triangle, which is this one, are making the angle. That's why we call included angle. And then that's the reason that we write side, angle, side. If you look at it, side, angle, side. Suppose if one angle, this angle in here, and you have two sides, and then two sides and the other angle over here are congruent, then it's not gonna be congruent because this angle, if it's here, then we're gonna say side, side, angle. which will not congruent. So make sure the angle in between those corresponding angle are congruent to other one. All right. So in here, when we say it, side AC is congruent to XZ, and then we prove that angle, which is going to make between, which is made by those two corresponding sides, which is angle C is equal to angle Z. Fine. Those are given because we already know it's in the diagram which is given. And CB is equal to ZY. CB is equal to ZY. Now we can say triangle ABC is congruent to triangle XYZ. Here's the one proof if you want to look into it. This is where we use all the things that we studied in basic geometry or MS geometry. If you look at this diagram, or you can say quadrilateral, they are giving already, the given is BC is congruent to DA. BC is equal to DA, okay? And then they're saying BC is parallel. See, that's why they put those two arrows. That's mean parallel. This bar is, one bar over here. So those two are equal. That's why they put that bar. In here, they are saying BC is parallel to AD. This line is parallel to AD. Now we know AC is the transversal, which is cutting. So we learned previously, if there's a parallel line, if a transversal going through that, the alternate interior angle, these two angles are congruent. We know that, okay? So now they're asking to prove triangle ABC is congruent to CDA, this triangle. The top triangle is congruent to bottom triangle, all right? Now, how do we prove it? This is called two-column proof. Pretty simple. The first thing, when we look at it, we have to prove, we have angle, we have one side. So we have side, angle, we have to prove another side, which is making these two angles are congruent. And then we are all set. So under side, angle, side. Or we have to prove all three sides, which is, we don't know the third side. But I will choose the angle because we know already alternate interior angles are congruent. So we know BC is congruent to DA. So we prove one side. We already know BC is parallel to AD. It's given. So that's why we put given over here. So therefore, we can say angle BCA is congruent to DAC. What is the reason? Alternate interior angles. I don't care if you put theorem. Those are, just put alternate interior angles, which is fine if I give you any questions. All right. Now, what can we say about this side? These two triangles are sharing this side. So what we can say, AC is congruent to CA, which is same thing. That's called reflexive property. Remember, reflexive property, you need to know it, okay? So we know, we made it one side angle and this side, another side are congruent to one side and angle, which is made by those two sides, or included angle, we can say, are congruent. So therefore, these two triangles are congruent. So that's why we say triangle ABC is congruent to triangle ACD. The postulate is side, angle, side, which is side, angle, side, side, angle, side. All right. So I hope you understand. And if you have any questions, please feel free to reach me and then we will work on it. Okay. And please do the checkpoint. There will be 2 questions and then see if you can do it. All right. And let me know if you need any help on it. Thank you.